Our first speaker on track one is going to be Iwan Eising. And I'm really excited for this because he's going to be talking about something that's really important to me as an implementation engineer for APISec, and that's shift left methodology.
Thank you, Jesse. Hi, and welcome to my session. API Stack DevOps, delivering APIs that behave securely. And obviously also welcome to the conference. Really cool. So as you know, my name is Iwan Eising, but more about me in a bit. So first, let me plug a few APISec University courses that are relevant to this session. All right. These four courses that you see are definitely worth completing. Of course, all courses are worth completing. So everything that you see on APISec University, definitely go through them. But these four are very relevant to today's session. They provide a lot of additional background that is super useful when you want to make sure your APIs behave securely. Okay, before you're heading off to do those courses and miss my session today, let me give you a quick overview of what the session is all about. If you still feel watching the recordings of the session and do those trainings first, that's completely up to you. All right. In this session, I will, of course, tell you a bit more about myself. It's always good to understand where the speaker is coming from, as it puts everything said in context. And as you will find out today, putting things in context is pretty important. Next, I will explain why this session is called SecDevOps instead of DevSecOps. Oh, don't worry, there is method to this madness. But after that, I will explain some of the terminology that will be used in this session that will lay the foundation for the meat of my session. And don't worry, no animals were harmed in any way to put that meat on those sessions' bones. No humans either. So just in case you wondered. Finally, I will explain what it means for an API to behave securely and how you can make your APIs behave securely as well. Of course, this wouldn't be a session about API security without covering the OWASP API security top 10. So that I will be doing as well. Don't worry, I won't explain what they are because I guess that you already know what they mean. Instead, I will explain how your APIs can behave in a way that you have less to worry about the OWASP API security top 10 risks. To be fair, I'm covering a lot, but there is even more I will not cover today. So, for example, I won't cover how to keep your executive leadership out of the European jails by complying with European regulations. And I won't cover how to secure those millions of euros for your cybersecurity budget. Millions you are not getting today, so your security is probably suffering from technical debt. Just to give you two examples of what will not be covered today. These topics are all covered, just like the topic of today's session, in my APISec University course, which I think is launched today. So that's pretty cool. The course is named Start Left APISec DevOps. And I'm pretty excited that it's launched today as I'm doing this presentation. A little bit more, as promised, short introduction about me so you can put my ramblings today in context. As I already mentioned, context is important. So you know my name, Iwan. It is pronounced as letter E, number one, and my last name is Eising. It's that stuff that you put on the cake. I have over 30 years of experience in delivering software-based products in a variety of roles like software engineer, and agile and DevOps coach, and enterprise architect, just to name a few. I've also been a computer science teacher to gifted children aged 6 to 12 in the Netherlands. I have fulfilled all of these roles in a variety of industries like finance, public transportation, education, utilities, etc. And that was for large organizations with 50,000 people servicing them, or also for small like startups with just two or three founders. I lived and worked all over the world, including the Netherlands, where I was born. So that's where I'm coming from. The United States, Scotland, Pakistan, Denmark, Egypt, Switzerland. And as I mentioned, currently I live and work in the United Arab Emirates in Dubai, where I'm the chief architect of a bank. Today, I stand before you as architect. I'm a flip thinker, a techfluencer, and iconoclast. I'm currently writing a book with the working title Software Engineering Done Right, the practice of delivering useful and usable software, it's perfectly safe to scan that QR code. This QR code will take you to a page with several links to get in touch with me, including my LinkedIn profile. And when you do scan the QR code, you'll also get a link to my Discord server. If you become a member, and you can request access to early access draft of my book in PDF format, as well as the source code, by the way. So it's all for free. When you have any feedback on the book, any content, format, scope, positive or negative, I really do appreciate it when you take a little bit of time to provide and send me that feedback. I write the book in the same way as I develop software, which means iterative and incremental, and I'm using feedback to make things better. So enough about me. Let's talk about secure APIs. And you might be asking yourself, why is he talking about SecDevOps? Isn't it DevSecOps? Didn't I hear about that? Or maybe saw an even presentation on that? Or, is this dude only trying to be iconoclastic? Well, yeah, maybe I am trying to be iconoclastic, but there is a very good reason for me to prefer SecDevOps over DevSecOps. See, security should be considered a business requirement. And like all other requirements, it must be used as an input to the delivery of software, especially when that software exposes APIs. So security is a business concern. And how secure a product must be is therefore a business decision. Depending on the security requirements, certain practices must be in place when delivering software-based products. And in this session, I will focus on the requirements related to security that software products must meet. Hence, sec before the dev and the ops. Security being shifted all the way to the left into the realms of the illustrious business. Because this is APISec Con, I will focus on APIs, but the concept of SecDevOps applies to all software products, not just APIs. So now you know why this is about SecDevOps instead of DevSecOps. Let's move on to the left, but not the far left just yet. Let's go just a wee bit to the right of the far left when it comes to APIs, which is the design of APIs. So there are different ways API first is interpreted. One such interpretation is that before the API is implemented, the API itself is described using OpenAPI, for example, when it concerns RESTful APIs. This is also referred to as contract-based development, but I typically use API-first design. Another interpretation of API first is that the API is developed first and next a client is developed that uses the API. In my opinion, this is a bad practice, but I won't go into details now, but let me know if you want to talk about it, but let me just say that it impedes zero trust. Instead, I will stick to API first design in today's session. So organizations that embrace API first design will find themselves in a fortunate position where API producer and API consumer can be developed in parallel, independent from each other by two different teams even, all based on the API's description, the contract. And this saves a lot of time, lead time, obviously, delivering new features with a shorter time to market. And I can tell you that's something that the business loves. Applying the API first design concept can be a challenge when the requirements for the API are not clear. In many organizations, requirements are very elaborate and typically presented in a human readable format, which is not necessarily a human understandable format. Human readable means it's in plain English or whatever language is common in your organization, and using well-written sentences that make for an easy to read document. I call these documents requirements novellas. The documents describe the required functionality, which makes sense because they are, after all, called functional requirements. Interestingly, requirement documents almost always describe what an application must be able to do, which functionality it must provide. And hardly ever is it described how that functionality is expected to be used to solve a business problem, even though that is exactly what the business requires, applications that helps them solving business problems. And this tendency to describe what an application can do makes it close to impossible to define APIs that will make the application useful and usable. To describe how an application is used to solve business problems, it is important to describe how an application should behave when it is used. What should be described is what scenario should play out for a user who finds herself in a particular problematic situation. So she can solve that problem using features of, of that application and consequently finds herself in a better or maybe even a perfect situation. We call these use case scenarios. And this is where behavior driven development comes into play, what we'll be describing on the next slide. So, the intention of behavior driven development is to describe how an application's features can be used in specific scenarios to solve specific business problems. Behavior driven development encourages collaboration between developers and testers and product stakeholders by using human understandable description of scenarios in which a feature is used. And a feature could actually be an API. Ideally, these scenarios are backed by automated tests. In these cases, behavior driven development serves as both specification and living documentation, resulting in testable requirements, which is, I can tell you, extremely awesome to have. I will show how this makes it possible to derive APIs directly from the requirements if you apply behavior driven development. So let's talk about requirements to solve problems, and that's on the next slide. Behavior driven development is about how the software can be used to generate business value. For this, it is important to understand the business domain and map features of the software to those business domains where the feature makes sense. This is where domain driven design comes into play, as its intent is to model the business in terms of business capabilities. Behavior driven development and domain driven design are therefore very much complementary practices, as they both share a focus on understanding and modeling the business domain. Domain driven design emphasizes collaboration between technical and domain experts to create a shared model expressed through what is commonly referred to as ubiquitous language. And ubiquitous language is the vocabulary that is used within a specific business domain. The same vocabulary should be used in describing the software's features. Behavior driven development builds on that same collaborative foundation, but it does focus on specifying system behavior through concrete testable examples. And it encourages conversations between developers, testers, and business stakeholders to define how the system should behave in various scenarios using natural language. And these scenarios are typically grounded in that same domain model. Ubiquitous language from domain driven design is used in that natural language, used to describe the various scenarios in which a feature is used. And I'll get to that with a few examples as well. In practice, behavior driven development helps validate and clarify the domain model produced by domain driven design. The examples in behavior driven development become executable specifications that reinforce the domain language, ensuring understanding and keep the model honest and testable. Meanwhile, domain driven design provides the structure and terminology that give behavior driven development scenarios real world meaning and consistency through the domain's ubiquitous language. When applying behavior driven development to define the requirements your application must meet, you start with defining which features the software should have. Unlike traditional requirements, features are described in terms of things you can do with the application to solve problems. And the next step is defining the various scenarios in which each feature is expected to be used. And the third step is to describe the state the application must be in at the start of each of these scenarios and what the state of the application will be when the feature is used. Let me show you with an example of a phone book application what all this means, because it probably sounds a little bit abstract for you. As I mentioned, the first step is identifying the features that would allow the user to use a phone book. One such feature would be adding a phone book number to the phone book. So we have a feature add phone number. Well, I guess this doesn't really make a lot of sense. Why store a phone number without storing the name of the person it belongs to, which is the contact? So let's redefine the feature and make it a feature that will be adding context, not just phone numbers. Here we go. Already our first iteration, and we have a huge improvement. The next step is identifying various scenarios in which the feature will be used. Let's start small and think of two obvious scenarios. When we click, we'll see them appear. Adding a new contact and attempting to add a contact that is already in the phone book. There are probably a lot more scenarios you can think of when it comes to adding contacts to a phone book, like adding a contact without a phone number, or adding a contact without a name, or adding a contact without a name and a phone number. The third step, as I mentioned, was to define the context in which the feature is used and what the outcome using that feature will be, which appears when we click. As you can see, each scenario has a different outcome when the starting state is different as well. And the scenarios describe how the phone book application behaves when a contact is added to the phone book with a different starting context. It is, of course, debatable whether the described behavior is desirable, especially behavior of the phone book in the scenario where there is already a contact with the same name, John Smith. It's pretty questionable. It implies that there can be only one John Smith, who is probably not that realistic. Although, in all honesty, I never met a person with the name John Smith, or at least I don't remember. So it seems to be an uncommon name after all. And I should definitely add, somebody John as my contact. Those of you familiar with developing REST APIs will probably already have been thinking that the contact is a JSON object with two fields, and that in the first scenario, the HTTP status code of the response will be a 201 created. And in the second scenario, it will be a 409 conflict. When you do my APISec course on this same topic, you'll actually learn why you shouldn't return a 409 if you want your API to behave securely. Well, if that's not really an incentive to do the course, I don't know what is. And this illustrates the benefit of describing requirements in terms of behavior instead of functionality, because now we describe this feature, and all you already know is that from a REST API perspective, you got a JSON object and you got two response codes already. You may have noticed that both scenarios are defined using a very specific format. And in behavior-driven development, scenarios are defined in the given, when, then format. Given a specific context in which the feature is used, when the feature is used in a specific way, then a specific outcome will be the result. And I'm using the word specific a lot, which is on purpose. In behavior-driven development, we want to be as specific as possible, hence the mentioning of a contact with the name John Smith instead of just contact in the example scenarios. And by being specific, it becomes a lot easier to identify edge cases and define scenarios describing those edge cases. For example, it made it unambiguously clear that there can be only one John Smith in existence. And like I said, whether that's realistic is debatable, but now you know that that's the outset. Because we are specific in behavior-driven development, we can easily identify edge cases. Like a contact with the same name already exists and how the application should behave in that case. Should we return an error? Should we return a 409? Or ask the user to confirm it's the new record, or just add the new contact as a duplicate? That's the behavior that you described in these specific cases. All right. With this simple example, let's go to ubiquitous language and see how that plays a role. I use some common terminology to explain the behavior of the phone book application. For example, I used wording like person, contact, phone number. But I didn't elaborate on what these mean because we all know what a person is. We know what a contact is, and we know what a phone number is, especially when we know that the context in which we're using this terminology is a phone book. We know what they mean. And with the context of a phone book, we already also know what an area code is, for example, and we know what a country code is. And to make the phone number complete, we also know what a subscriber number is. Take this same terminology, but put it in a different context. For example, let's assume the context is city planning. In this context, the area code has a completely different meaning. It will refer to an area in a city that is identified by a code, because different people may use different names for the same area, which will be confusing. When we talk about context within which certain terminology is used, we talk about what is called in domain-driven design a bounded context. The terminology used within a bounded context is called the bounded context ubiquitous language. Knowing the bounded context, it is therefore critical to understand a system's desired behavior. Remember, I said that context is really important in this session. Bounded contexts are also very relevant when it comes to regulatory and security requirements that are associated with those regulations. Regulatory requirements are often relevant within a specific context, and it is important to know the context in order to interpret the regulatory requirements correctly. For example, HIPAA is mainly relevant in healthcare. PCI DSS is especially relevant in the payment card industry. Many of these regulations have a security component defined. And in recent years, we see a trend that regulators require organizations demonstrably comply with those regulations. Regulations like the EU's GDPR and more recently NIS2 and the US's Executive Order 14028 require companies to be able to prove that they comply with regulations. That includes that their software is secure by design, by development, and by operation. Yep, here we are, Sec, Dev, and Ops. Talk about bounded context and security is therefore important. Bounded contexts are actually even more interesting when turning this security component into security requirements. As I mentioned, within a bounded context, a context-specific vocabulary is used, ubiquitous language. Let's see what that means for a phone number by clicking. For a phone number, we can say the following. That's what's on this screen here. And like every other vocabulary, ubiquitous language consists of nouns and relations between nouns, which forms a model, the information model of a bounded context. And by the way, it's called ubiquitous because it is the language that prevails within that particular context. And you should use the same terminology across the complete software delivery lifecycle, including your API specifications. So when we look closely at this very verbose description of the context of a phone number, and we focus on the nouns and we click, we see them appear. It becomes a straightforward process to determine the information model. And this is the information model of a phone book, the nouns and their relations. Every bounded context has an information model, which is based on the ubiquitous language of that bounded context. As a rule of thumb, you should be able to find every noun in the vocabulary of the bounded context in the information model and the other way around. Every entity in the information model must be part of the ubiquitous language of the bounded context. I know this is not really the way it is supposed to be done in domain-driven development, but it has proven to me to be a very effective way for organizations that are not familiar with DDD or have just started adopting it. We can apply information security onto the information model. For each entity in the model, as well as each relation in the model, we can, for example, determine how confidential the information is, who can access the information, and under which circumstances. Again, this is not a technical aspect, it is a business aspect. The confidentiality rating of a noun also determines who can access that information through the API. which links with numbers 1 and 3 of the OWASP API security top 10. Look it up. Let's take another look at our phone book application. So what we know about phone numbers when searching for them, let's look at the case where the person is a member of a household. This is where behavior-driven development shows its immense value. When you click to the next one, when searching for a phone number of Karen Smith, we get the phone number by which we can reach Karen. But when we search for the owner of that number, we won't get Karen's name, but instead we get the name of the household Karen is a member of. Makes sense, right? Or does it? So I'm using this example. Why is this scenario significant as an example? Well, this is actually a case I encountered in real life. The initial requirement was written as a functionality of the application, something very verbose like the last sentence, when the search is done on the landline number, the household is returned, was interpreted by the developers as all members of the household are returned. Because when you asked for the phone number of a member of the household, you would get the household's phone number. So the inverse should provide all members of the household. This made totally sense to them. And it does sound logical, and probably it's the easiest way to implement as well. This is, of course, problematic because the search would result in disclosure of a lot of information previously unknown to the person. Requesting the information, it would disclose a lot of person's identifiable information, which is undesirable, obviously. The security team had reviewed the requirement as it is shown here and considered it adequately addressing their concerns of disclosing too much information. It was, at least to them, clear that the name of the household was going to be returned. It was deemed GDPR proof, so to speak. The developers understood it differently, and we only found out literally days before releasing the functionality into production. We stopped the release and fixed it and released it 3 months later. That's 3 months of not having the revenue generated by this feature. Because had we applied BDD, then the erroneous interpretation would have been this. This would have raised red flags with the security team during the requirement stage, as it is now unambiguously wrong. The security team would have seen the problem and rephrased the scenario. And this is an example of how you can prevent the disclosure of too much information by defining a behavior of the application that prevents it by design. This would have been identified during the requirements and engineering phase, as I mentioned, and the correct behavior would have been delivered on time, generating revenue 3 months earlier than we ended up with. All right, so we've covered a lot of ground in this session. There's a lot more, by the way, and that's covered in my APISec University course, Start Left APISec DevOps. It's a 2-part course, and part 1 is available. Today, I explained what APIs that behave securely are. You understand how when you do the course, you also understand how public, private, and partner APIs are different. But in this session, I'm taking you through the practice of behavior-driven development and using domain-driven design to identify where in your API designs you need to provide the right level of security. By the way, this is also very much covered in my book, Software Engineering Done Right, the practice of delivering useful and usable products. Click on that or scan that QR code and ask for access to the early drafts. They're all free. And I do hope that you enjoyed the session. And of course, that it inspired you to complete the first part of my APISec course. Thank you. My name is Iwan Eising, aka Architect. And do scan that code and I'll connect with you anywhere you want. Thanks,
Thank you.
everybody.